Hello students. So in this video I will be taking a different kind of signal to solve the convolution problem. Here two continuous time signals were given, x1 of t and x2 of t. So we have to perform convolution for these two signals. If you look at the signal, both are rectangular signals here, and both signals are varying from 0 to 1 and having the same amplitude. Now for this case, it's up to you. Either you can go with x1 of t convolved with x2 of t, or you can go with x2 of t convolved with x1 of t. That doesn't make any difference. So y of t is equal to x1 of t convolved with x2 of t. So based on this, we'll get y of t is equal to tau varying from minus infinity to plus infinity, x1 of tau, x2 of t minus tau d tau. Call this as equation 1. Now let's plot x1 of tau and x2 of t minus tau here. So this is x1 of tau varying between 0 and 1 having amplitude 1. Now x2 of t minus tau, x2 of t minus tau. First I will plot x2 of tau and then I will show you how to get x2 of t minus tau. So this is x2 of tau, okay, and if you take the reversal version of this, considering t is equal to 0, considering for t is equal to 0, you will get the signal like this, and this point is called t minus 1 and this one is 0, that is tau is equal to t here. Okay, so this is the signal here. Now this signal is varying from t minus 1 to t, that is the time index with respect to time index tau, and this signal x1 of tau is from 0 to 1. So let's start performing convolution operation. I will take the first case, case 1. So here, so this is the signal 0 and 1. Now I will take the shifting signal. I'll keep this t less than t. That means I am finding the region where there is no overlapping here. So this is my signal from t minus 1 to t having amplitude 1. This is my x2 of t minus tau. Okay, as you can see, there is no overlapping. So no overlapping means y of t will become 0. So the case we define this for t less than 0, that is this t is less than 0. What happens to the signal? So there is no overlapping. Therefore, x1 of tau into x2 of t minus tau will be 0. So if these two are 0, therefore y of t is equal to 0. So this is the first case. In the next case, I will move this t, keep it somewhere here, and let's see what happens to the signal y of t. So case 2, so this is x1 of tau varying from 0 to 1, and my time shifting signal. So I will keep this t here. So if you observe this, both are having only one division. That means the time index are from 0 to 1, 0 to 1. So that means this signal will also have the range of only one division, that is from here to here. You can say if you want to define this, both are, this is my x2 of t minus tau with amplitude 1. So this is also having amplitude 1. Now if you observe, this is the overlapping region that is varying from 0 to t, and how to define the condition here. So this condition is for t is less than 1 and greater than 0. So t is greater than 0, less than 1. As I told you, you can take this case into different one. That is, if you observe this, it is halfway through between 0 and 1, and if you observe, it will be greater than minus 1, this other end. You can take the limit by this end or by this end, both will give you the same limit. Okay, you can take t minus 1 is greater than minus 1, less than 0, then also you will get the same limit. Okay, so that I am not going to concentrate on now. So this t is between 0 and 1, and let's see what happens to y of t in this particular duration. So now t is varying from 0 to 1, sorry, 0 to t. The limit is from 0 to t. This is the overlapping region, and we have to perform integration of these two, x1 of tau convolved with x2 of tau. Now in this particular duration 0 to t, both are having the same amplitude, that is 1 and 1. So you will get tau, limit is 0 and t. If you apply the limit and simplify, you will get the answer as t here. So y of t is equal to t between 0 and 1. In the next case, I will move this t here. So that means this t minus 1 will be in between 0 and 1, and this t will be outside that one. Okay, so let's take this condition here. Case 3. So I prefer you first complete the plot and then take the limit, then it will be easier for you to apply the limits or take the limits. So this signal is from 0 to 1, and I will take some point here, that is 2, amplitude 1. So this is x1 of tau, and now I am placing this 2t in between 1 and 2. So this is also having the same 1 as the time index division. Now t minus 1 is inside this t here. Now you can take the limit in any way you want. I will show what happens to this. So I'll take this first one for t less than 2 greater than 1. So this is the first case. Or if you want to go with this end, so t minus 1 is less than 1 but greater than 0. So move 1 here, so that becomes plus 1, and here 1 plus 1, that is 2. So you will get the same limit. Okay. Now for this duration, what is y of t? Y of t is equal to, now the overlapping region is this, that is from t minus 1 to 1. So t minus 1 to 1, x1 of tau, x2 of t minus tau d tau. So this is the overlapping region. Now in this particular region, the value of x1 of tau and x2 of tau is 1. So you will get tau after integration. Apply the limits, and if you simplify this, you should get the answer as minus t plus 2, or you can write it as 2 minus t. So y of t is 2 minus t between 1 and 2. Okay. So next case, case 4. So this is my x1 of tau and taking this next signal. Now observe here, I will shift this. So this t minus 1 will also move out here as I am shifting one division at a time. So if you move, keep this outside. So here the time index is 2, here it is 3. Now I have moved this signal, that is shifting one, x2 of t minus tau with amplitude 1 here. So this is t minus 1 and this is t. Now you can consider the limit in both the cases. Now simply I define this for t less than 3 greater than 2. Okay. Now for this duration, what happens? There is no overlapping. As you can see, the signals are not overlapping. Therefore, x1 of tau and x2 of t minus tau, the product of these two will be 0. So that means y of t will also be 0. Now if you observe this, if you take further steps, then it will be completely 0. So for simplicity purpose, here you can see the signal existing only for t less than or equal to 2. Now for values of t greater than 2, there is no overlapping. So we can conclude like this, and summarizing all the values of y of t, we can write the final answer. Y of t is equal to, so we have different cases here with different limits. So in the first case, for t less than 0, there is no overlapping. Y of t is 0. You can see this, y of t is 0 for t less than 0. So that is the first case. So let's write it here. Y of t is 0 for t less than 0. So in the next case, second case, between 0 and 1, what is the value of this y of t? Y of t is equal to t. So let's write that y of t is equal to t for value of t greater than or equal to 1, less than or equal to 0. Next case, for value of t between 1 and 2, so y of t is 2 minus t or minus t plus 2. So y of t is 2 minus t between 1 and 2. Okay. And at last, for value of t greater than 2, y of t is 0. So y of t is 0 for t greater than 2. So this is the final answer. You can extend this here till here. So this is the final answer for y of t. Now if you want to plot this, if you want to plot y of t, so it says for values of t less than 0, value y of t is 0. Now for value of t less than 0, y of t is 0, that means this part is completely 0, which we are not plotting that. Now from 0 to 1, 0 to 1, what is the value here? It will be t. So that is nothing but a ramp function. But if you want to get it clarified, just put the value here. You can put y of 0, then you will get, because y of t is equal to t. If you put t is equal to 0, you will get 0. And at y of 1, so you will put t is equal to 1, you will get 1 here. So at y of 0, amplitude is 0, and at y of 1, the amplitude is 1. Join this. This is the signal between 0 and 1. Now coming to 1 to 2, what is the value? 2 minus t is there. So y of t is equal to 2 minus t. Now I want the signal between 1 and 2. Let's apply the value. Y of 1 is 2 minus 1, that is equal to 1, and y of 2 is 2 minus 2, that is equal to 0. So at y of 1, amplitude should be 1. You can see the amplitude is already 1 here. Now at y of 2, at y of 2, amplitude is 0. So that means the signal starts from 1 and goes all the way to 0. Okay, so this is a simple way to plot complete your plot, and it says for value of t greater than 2, y of t will be 0, and from here onwards the signal will be 0 for the remaining values. So this is the plot of y of t. Okay, and from the basics of signals, you can say that if you multiply a unit step function, you will get a ramp function. Sorry, my mistake. If you integrate a unit step function, you will get a ramp function. Unit step function will always have the amplitude 1 here. So you can see this. Here we have a rectangular signals, both of them having a same amplitude. Amplitude is 1. So that's why both will end up with giving a ramp function. One is an increasing slope or increasing ramp, another one is a decreasing ramp. Okay, so this is another kind of example. Hope you have understood the method. If you have any kind of queries, do reply or I can put a comment. Thank you for your time.